Assembly Language Tutorials Part 5 Section 1. In Section 1 we'll talk about procedures. I don't want to waste a lot of slides and jump through it quickly, so here is how you define procedure. A procedure works with some concepts what we know as a stack. Now a stack is different from the stack that we have heard of in different programming languages like C++ or Java. It's not completely not related to that. There is something called hardware stack, which is managed by the CPU itself. So just bear in mind it's different from the other software stack. Here we are talking about hardware stack, right? We are programming with the assembly, so we gotta deal with hardware. Let's see a quick demo. So the program basically takes two numbers, num1 and num2, and adds them and shove it into sum. So this is our procedure. So this is a standard way to define procedure. This is the only way, by the way. So name, then proc. This sounds familiar, like main and proc, main and np in our previous programs. So here we have, like, as our code gets bigger and bigger, we want to split it. It's also possible to call another procedure from this procedure. So I could have a call instruction right there. So just a proof of concept. So this is how we call a procedure. You just call and give it a name, right? That's all. A name and proxy, which is identical to these guys. And this is important. Without this, it will crash. The application will crash. So you need to have a return statement over there, so that it tells the CPU that, hey, I'm done processing these instructions, and now you could resume what, right? Resume what? Now you have called this procedure, now everything is here, now you return. So where do you resume? How do you resume your program execution? So I will show you what happens there in the memory. So let's set a breakpoint here and verify that our program works. So here we have a watch variable. How you add a watch variable is quite simple. Go to Windows, debug Windows, watch, and watch 1. So you will get that. So you would get something like this. So it would be floating like this, or it would be probably coming like this. So you just drag it, and you see that middle section. The middle section is highlighted. If you take it left, it gets towards the sideways. So you keep it inside the middle section, and it would attach to the side of the registers. Quite simple. Now it's doesn't have any value because this execution hasn't happened. This is the guy, this ex value we have. So you can see that when I hover over it, ex already has the value 19. Now 10 plus 15, how the hell it is 19? It's not, it's in hex. So you move it to sum. Now the sum has the value 19. So sure enough, we have hex 19, and the decimal would be 25. Okay, so this is like how we invoke an external function. Now what happens in the memory? For that we need a debugger. And as we are learning assembly, not to just learn assembly, we want to do some cool stuff, and I'm in security background, and I will show you a cool tool today. This is called Immunity Debugger. So here I open that program, the same program. Now when the immunity starts, you would see towards the right we have paused, that yellow highlighted, red font paused. So you hit this play button for the first time. So now you would see the same instructions. See, our call procedure is here, this guy over here. So our execution is starting at this offset. Now what is the offset? Offset is just memory location, put it simply. So this is the first instruction. This next instruction, line by line, it will be executed. So here we are actually making the call. How do we know that? Because this is our instruction, right? In our source code we have that instruction, XOR EX EX. So So we know that this is when we are making the function call. And moreover, if you see that had the XOR ex not been there, how we would identify that what's happening there. So if you see that procedure 0005102A, so now I will remove all these breakpoints, so just to show you that. So here we are, right? So call that thing over here, and that thing is here. Move ex dword ptr. So this is the thing, right? Move ex num1. So we could write it this way as well. We discussed about ptr, like when we are putting something from smaller to bigger one, like ex is bigger. So we have this thing. Now this is like indexing thing. We talked about this as well. So this is kind of the index for ds. So this is something else I will probably talk about that later. I wouldn't want to confuse you guys, so explaining too much. So this is in a nutshell what's happening is 0005102A. So this is our execution over here, and then add and then move. Here we are moving the EAX into DS. So DS is probably destination. Now maybe DS is a pointer to sum, because we do not see the sum variable over here, right? The sum is nowhere here, so its DS is kind of a pointer to that. Now this PTR is not the pointer, so this holds our value. You see that DS colon 5400 DS colon 50. So this think of it like an identifier, to put it simply. I move the value of EX into this and then return. So if I run this, so you see that now we are over here, right? So the highlight came to call. Now it went this way because we didn't set a breakpoint here. I'll run this again to show you more clearly. Run. You could also press F9 instead of the play button. So now we are over there. The call instruction is there. Now look closely, the highlight would flip, would like jump from there. See, it jumped from the call procedure to move EAX. So that's what's happening. The execution has come from there to here, right? And then the next instruction, and then return. So when the return is executed, how the computer knows that it has to go to the XOR, that I will explain. So now I hope you got this idea. Now we'll cover that how it came back to XOR. Now if you see over here, we have a value like 51021. So that's the address of the next instruction. But where we are here, right? The highlight over there, the call. So it has to come back. So this guy, this 51021, this guy, it has to be stored somewhere. Where we store it? We store it in the stack. Now that's the stack I was talking about. So the runtime stack, it's like the CPU manages that stack. It keeps those data inside the memory. So let's see that. Now towards the right, now Immunity Debugger has 4 sections. This is software application to debugger application. Towards the left, you see disassembly of the same program. Now here there are a lot of other codes also. Pay do not much attention to that. Our concern is this much only. Towards the right, you have registers. We have seen some of them in the Visual Studio as well. Here you have hex dump, and here this guy, this is the stack. So you these, I hope these sounds familiar. ESP and EBP, these are extended stack pointer and extended base pointer. This guy points to the top of the stack, and this to the base of the stack. So the highlight changed. So if I go to ESP, so it is over here. Now look closely what happens. Pay attention to this guy over here, right? 76EA8 something. So you see that, and you remember this address as well, 51021. Now pay attention to this because there are so many moving pieces, but for clarity I'll reiterate. remember this guy 51021 and look closely here, right? I will hit the play button now. You ready? You saw something? That address is actually stored here, right? That's how what CPU is doing is it's storing the address of the next instruction into the stack. Now we move on, we add it, we move the value from the EX to the variable. It's kind of a identifier for the sum variable, some weird name. Now return I have to set a breakpoint there, that's why it missed and jumped to the push 0. So now you remember that this address over here 51021, so I will place a breakpoint there, and you now know this, that this is the top of the stack. Go to EBP, is the base of the stack. Go to ESP, go to the top of the stack. This is the top of the stack. So press F9, procedure, and the top of the stack changed. We have the value 51021. Now we are over here, move instruction, because we already made the call to the procedure. Move and then add and then move, then return, then now we have XOR. So I hope you guys enjoyed this video, and I will put this source code in GitHub and play around these tools. So this is a very good debugger and eventually we would jump into exploit development, reverse engineering as well. So this immunity debugger is a user mode debugger. In an operating system there are two modes, kernel mode and user mode. For user mode, all kind of exploitation, we can see the memory analysis, everything in the immunity debugger. It's a very powerful tool. So I will catch you guys in the next video, and feel free to post comment on these. So I'm making the videos, and if you have any questions, so put your comments, ask questions, I would explain them. And subscribe so that it makes me happy as well, and you will receive notification as well when I upload new videos. And have a good day. Bye bye.